Okay, so hello everyone, my name is Vikash and today we are going to solve this weekly contest 485 of the LeetCode. So, first of all, comment that how many questions you have solved, so I know that how on which question I have to focus more. Yeah, please comment fast. And yeah, first of all, congratulations guys that you wake up that much early in the winter and give the contest. Right. Okay, so now let's just start the solution. Okay, so let's start with the first question, which is vowel consonant score. So in this question, what we are given is we have a string of lowercase English letters, but there also will be some spaces and some digits also. And okay, what is V? So let V be the number of vowels in S and C be the number of consonants in S. So the vowel adds the A, E, I, O, U and the other letter in English alphabet are consonant. And then there is some score which is defined as if C is equal to 0, then score is just V divided by C, else the score is 0. So in this, we don't have to do much. We just have to find that in every string, how many consonants are there and how many vowels are there, right? And then just count the score according to this thing. I think this was pretty easy and I hope that everyone solved it. So in this, what I have done is just the two variables V and C. V is for number of vowels and C is for number of consonants. And then a loop. So we are just iterating all of the characters in this string S. And then we are checking if the current character is one of these elements, which means that the character is vowel. We will just add the C++. Or if Si is greater than equal to A and Si is less than equal to Z. So what I mean by this is I'm checking that if the current character is a English letter, a English alphabet, then only I know that the current letter is English alphabet and not this thing. Then I know that it is going to be mm, a vowel, right? I think I just did a small mistake in the variable naming, but it's okay. Doesn't matter that much. So if the v is equal to 0, then I just know that the answer is 0. Else, I just return c divided by v, and that was it in the code. Yeah, so if someone has some doubt in this, you can ask me now. Okay, so now let me move to the question number two. It was a pretty good question for like question two. Let's read it. So in this, what we are given is that we have two integer arrays. One is cost and one is capacity, both of length and the cost of I represent the purchase cost of ith machine and capacity of I represent its performance capacity. Then we are given some integer budget and we have to select at most two. So just read this carefully. This is at most two, not exactly two yet. And at most two distinct machines such that the total cost of the selected machine is less than, again, strictly less than the budget. And we have to find what is the maximum achievable capacity of the selected machines we can get. Okay, so let's take by some test case. Let's see. So we have this test case, and let's say we have budget is equal to 10, and we have this cost. We have sorted this in decreasing order. Doesn't matter by much. Okay. Now, let's say what we can see. What will be the brute force approach? The brute force approach would be like you check for all of the pairs what is their budget and what is the sum of the capacity. But of course, the cost and n is still 25, so you cannot apply the brute force. You have to think somewhere for the O of n or O of n log n approach in this. So let's say, what is the observation like? What for something, can you like find the answer, right? Because we like in this we have to go from n square to n approach. Okay, so let's try to say that, like, see what is answer going to look like for everyone. So let's say if for first machine we choose this 15, right? Of course we cannot choose this 15 because the budget is only 12, so we cannot choose this. What if we choose this 10? So if as the first machine we choose 10, then I know then I can either get this 1, like the machine of this cost 1, or I can get this machine of this cost 2 with this, because the sum of 10 and 2 is going to be 12. Which, oh sorry, I cannot take this thing because this is like strictly less than. So apologies for this. I cannot take this 2 because the sum is going to be 12. But I want strictly less than, like, I can take this one only. So like this would be going to be one pair, and the sum of capacity is going to be 8 for it. Okay, let's see some other cases. What about this 6? I know that for this 6, I can take this one because with this 6 and 1, I know that sum is going to be 7, which is less than this 12. I can take this 2 also. Okay, so because the sum is going to be 8. Or I can take this 5 also because the sum is going to be 11. So I know then if I have to combine something with this 6, I can combine any of these three elements, any of these three elements. So which element I will combine? Of course, the element with the maximum capacity from all of this. So in this, one observation was that, like, I have already chosen if one element. If I have already chosen one element, let's write the observation. Yeah. So if I have chosen one element, just a second, one element, then for the other element, for then to choose the other element, I know that choices is going to be a continuous range, continuous range. That is that okay? Like, right, it is going to be a continuous range. So therefore, I have to think, I have to use of this fact. I have to use this fact. So like, what is happening? What is happening? Let's see. Like for this 10, I know that the range was something like this. But then I come to this 6. I come to this 6. What I mean is that I fix one machine. That I fix that one of my machine is going to be this, of course, 6. Then what is the range of the options I have? The range of the option is now this thing. So I know that when I go this way, the range of the option is increasing order. So somewhere I can use the two pointer approach to find the max element, right? So that's all we have to do in this. What we have to do is we are at some element. Okay, so what do we have to first we have to do is find the answer if we take only one machine, and which is going to be very simple, right? We just go at each machine, and if its cost is like mm, sorry, so like we will iterate on all of the machine and we'll ask that, hey, what is your cost? Like he will say his cost is 10, so I know that I can take this machine. Like currently I am seeing if I want to take exactly one machine, and I can take this exactly one machine, and I will say that the capacity is gonna be 6. Then I go at this one, and I can take this capacity is 9. I will take the maximum capacity. So the case for only one machine, this is very simple, right? And then for two machines, for two machines, I know that I can sort the elements according to the cost of it, cost of them. And then I know that it is going to be a continuous segment, and that's all I have to do. So I have just to like have a pointer. Sorry, I have to. Okay, I should have a pointer which shows that how many elements I can take from this right side. Right, so like I know that this is going to be suffix, and I will just say how many elements I can take from right for some element here, and I will just take the maximum of 10. Then I go from this 10 to 6, and again now I modify this thing because I know that cost is now the cost in buying the first machine is now decreased, like right 10 to 6. So now I have 4 extra budget. I can go in left side. Is it clear? So now my pointer will move in this side also, the second pointer. My range will become more now. So that's what you have to do in this. Let's see the code. Okay, what I did in the code, I make the new array, which is just the combined version of cost and capacity. So yeah, I can just sort them easily. Okay, so I just combine them with cost and capacity and then sort them in descending order. Okay, so I have just used sort to sort them in ascending and then reverse so that my array will now be in the descending order. Yeah, of course I can do greater right here greater, but I like I was in a hurry, so I just wrote this. Now what we store is we store the suffix max array. Now what is this suffix max array? The suffix max array is nothing but it will just store the it will just store the the like the ith element will store the maximum of the this suffix, right? So now like my suffix of 1 here would store the maximum of this element, oh sorry, maximum of this range, right? So like in this case my uh, suffix array is going to be like 9 9 9 9. The range is 5 5 and 2, right? So like this 5 is the maximum of these two elements, this 9 is the maximum of this 4 elements, this 9 is also the maximum of this thing, right? So that's it. This is the suffix array I made, and then it's just a two pointer approach. I have the pointer which is currently at n, so it's just out of bound, and answer is equal to 0. In this thing I check if I take exactly one element, right? So the cost is less than budget, then I know that I can take this element, ith element, and then I do this, that answer is equal to maximum of answer and the capacity of this ith machine. That's it. Now comes the main part in this. What I do. So what I do is currently I iterate from all the elements, and let's say how much money I have. I do money is equal to budget, the current budget I have, minus the cost to buy this current machine, minus one. Okay, why I did this minus one? So like I did this greater than equal to here, but then I remembered that I have to have for strictly. Let's just remove this. Okay, this was it. Okay, just ignore the minus one. Right. So now the money I have is budget minus the the money I used to buy this one machine, this ith machine, right? And if money is less than zero, then of course I cannot buy anything. So just continue from this. But then the P2 is equal to max of this thing. Okay, why I did this thing? This is like, very important. This thing was like the corner case of this code, right? Now, what do I mean by this thing? So let's say, just a second. Okay, let us say that I am currently at this element, and the range I can take is this one, right? Let's say the budget I have is pretty big. Let's say it is around 1000 or 10,000. So for this 10, I can take all of the elements in this, right? Like I can take any of from this. But now when I move from 10 to 6, I know that this 6 is already taken. So now I have to reduce this segment, reduce this range. That's what I do in this. I do that P2 would be maximum of this thing, I plus 1, right? This should be this, I plus 1. It should not be in the left of this. So that's what I just do. And this thing is to check if I can take the P2 minus I1, if I can take this element and also the cost of this is less than money, then I just come at this P2, right? So my P2 will just store that how many elements I can take, and that's it. If P2 is equal to n, then I mean I know that I cannot take any of the elements, right? Because it is at n. It is at n at which position I have just defined it or initialized it. So I cannot take any of the machine as the second machine. So I just take continue. Else I just take the my capacity would be the capacity of the current machine plus the maximum among this range. Right? My suffix gives the maximum of this suffix from P2. That's it, and then I just return the answer. So I hope this thing is clear to you. So if anyone has some doubt, you can ask me right now. And yeah, this was a pretty good question of two-pointer approach. So that's it. So let us move to this Q3 problem, which was like a kind of unique problem if you do only code forces or code step or other thing. Because this in this question you have to design a system, but it was not that much tough. Okay, let's say what is the let's read the question. So in this we are asked to design an auction system that manages some bids from multiple users in real time, and in this each bid have a user ID, like ID of the person who did the bid, a item ID, so on which item the person did the bid, and the bid amount, how much bid the person did. Okay, so this we have these three attributes, and in the system class what we have to do is we have to initialize this thing, or okay, and the other function is the add bid. In this function what we have to do is some person adds a new bid on the item ID by the person user ID, and the bid amount is this thing, right? And if he has already made the bid, then we will just replace it with a new bid amount, right? And that second thing is this update bid, in which the person with user ID which have already made some bid on the item ID will now change his bid to the new amount. And in this also we have guaranteed that the old bid exists. And the thing is remove bid. It is just we just remove the bid from this user ID to item ID. And this is our query function. So what is the query? So the query is like get highest bidder on the item ID, right? On some ID. we will ask that which person has made the highest bid currently, and we have to return the ID of that person, and that's it. So, hmm, what can we say on this? So this was a not that much tough question, and like usually the question on making some system are not that tough. You just have to think on the time complexity and space complexity. We know that user ID and item ID can be till 5 into 1 is 4. So what we can do in this? So let's say let's say we have only one, right? So the way to think for some logic or the way to find some observation is just like you have some variable and you just fix some variable and then find for some solution, or you have to think for many cases, but you just say what will happen for one case, right? So let's just take the simpler question, right? What if what if we just have the one item in this, right? Let us say we have only one item. Then for this one item, how should we how sh should we store the value, and data structure which data structure would be best for us, right? We have to think for this. So I know that what will I have is that some values like some pairs in which I will have the bid and the person ID who did the bid, and I need to find the maximum among this. So I can first think of some data structures like priority queue or set, but thing is, the thing is that I also have to remove some bits, right? So I know that priority queue will not work. The set would be best in our case. But that's it. So what I say is that I have just make the simpler problems. Like what if I have just one item, and then if I have just one item, then I know that I don't care about items. I just have to care about the person and what bid he did. And in the query, I have to find the maximum of this, right? So how should I store that? And then I just analyze it for some data structures, and I found that set would be the best in our case, right? Because we can delete it from this easily, we can find the maximum element easily, and also we can update it easily, right? So I know that set would be the best option in this case. Okay, how we will do all of the operation from this set? So let's say from the set, I will have the in the set I will store the bid and the person ID because I need to sort persons according to their bid value. That's why I will store the bid first and then the person ID, right? So how we will do the add operation? So add operation is just adding the pair. But what if the bid some bid from this person already exist. So what exists? Yeah. So what will you do in this case? So in this, you have to find the pair that. So first you have to check if some bid exists from this person, and then you have to find that pair, and then so you have to check, then find that pair, and then just delete it, and then add the new pair, right? So that's it we have to do. Now the problem is about this thing. How do we check if some bid already exists from that person, or how we will find that pair. So of course there are many ways. You can use the lower bound approach to find if some pair of that this person exists, or sorry, you cannot find the lower bound approach. You can have so the best thing you can say is that you cannot find the person, because the person is the second attribute in our set, right? The values will be stored according to that pair. What you can store is, what if you can just store somewhere else, somewhere else, the bid of this person, the bid of this person, right? That's the easiest approach I can find. What will I do is, I can have some vector or map. Let's say map would be better in this case. And the map of this person would give me the bid he did, and of course it will be 0, because in the map default value is 0 if he did not he did not did any bid, right? So we can store this thing in map. So when we have to check this thing, what we will do is we will ask this map that, hey, what is the bid of this person? And if it returns 0, then I know that it is its first bid. So I don't have to delete anything. I just add a new pair. And if it did some bid, then I will just say erase what will we erase? We will erase this bid value, or the bid this person did, which is this thing, which is its bid, and the person. We will remove this thing. So we will remove this thing and then add our this new pair. Okay, what we will do in the update thing. So in the update thing, it is also the same as this add function. You don't have to do anything else. We in this we just know that there always exists the pair. Like the person would always have done some bid. So that's it. What we will do is, again we will ask this person what bid he did. Then we will erase this thing and add the new pair. So this was the same as add function. You don't have to do anything else in this. What about remove function? What we'll do about remove function? So in the remove function, of course, we will given the person name and not the bid. So we will again ask that, hey, what is the bid this person did? And then we will get this map of person, which will give the value of this bid. And then again, we will do this operation. Yeah, so that's it. We just do this operation, the remove. So yeah, the all of the operation are like kinda similar. You don't have to do much this. And how to find the highest bid? How to find the highest bid? It's also easy. If you know about set, we know that the last value, the last element is highest, is highest. So we will just ask in the set, hey, what is the last element you have? And I know that will be the highest, and I will have some pair, right? I will have this bid and the person, and in the last element, this bid would be highest, right? Because in the pair, we know that the things are sorted according to first element, right? So this is the important thing you have to remember, right? And then I will just say that, hey, what is the person ID of this last element? And I will just return it, right? I will just return it. So that's it. So this was the case. Was the case if we have only one item. But what if we have multiple items? Okay, so let's say what will be the time complexity or space complexity for only one item. So this thing would be have like one pair per one query, right? This thing also will add or remove one pair per one query, and this thing also remove one pair one per one one pair per one query. So we know that the size is like bounded for queries. So like my time complexity is like sorry, space complexity is like O of queries or something, right? Because I know that maximum one pair would be added to just manage some function, right? Manage one query, right? So I know that this is the thing. So that's it. The thing is that you can just make some vector for all of the items and then check for everything, right? So that was it. What we do in this thing is make some vector of this set of pair, right? So in this we made a set of pair for only one item, right? But in this we just check for all of the items, right? For all of, like, I have made the vector of all 1 5 elements, and we will just check for all of the items, and this will not give us uh any MLE or TLE, because we know that the 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 size is depend on the query, right? So this thing is like this cost is my cost when the function is called, right? I only made this thing only once. Oh, sorry, I make the vector of set of pair only once of size 25, and then in all of this thing, the space complexity is going to be of q. The only one pair is going to be added, right? Okay, so that's it. We just check for all of the vector. Okay, all of the items differently, right? So let's see the code. What I did is I know that the number of different items are going to be till like 5 into 24, but I just did 25. I doesn't care much about the memory. Then in the vector, what I stored is a set of pair of pair. Now, this set is what we are talking about in the whiteboard, right? This set, this data structure. The difference is that this set is like now we have multiple sets. And what we do in this map? What we'll do in this map? So again, like here we discussed that the map, where is the map? This map. The map stored the map of some person. But we know that we have now two variables in the map. We have two variables in the map. So what are the two variables? The two variables in the map is the user and the item he has, right? So that's it. I make the map of pair, or I can make the vector of map. You can choose anything you like. So in this, I choose the map of pair, and when the okay now this thing is just initializing my vector of size infinite, and let's say for now all of the function, right? In this add bid. So what I do is I first check that, hey, I ask this map that, hey, if the person with user ID has made the bid on this item. Now, if this is not true, this is not zero, then I know that he had made the bid with the value of this map of this thing, right? So now in the vec of item ID, right? So I access the set of this item ID, right? The set which is for this item ID is vec of item ID, and then from this set I erase this value. What I'm erasing is the bid this person did, and what is user ID is. I erase this thing, and then I modify this thing, right? I modify this thing. I'll say that now this person, this person with this user ID on this item has the bid of this bid amount, right? Don't forget to like do change this thing also. And I change this, and in the vector, like in the set of this current item, which is the vec of item ID, I insert now this new bid amount and user ID. That's it. Now in the update bit, it is I just copy pasted this thing, right? That's nothing much to do. Like the only thing is that you just have to remove this thing, but doesn't matter because the difference between update bit and add bit is just that we have guaranteed that this bit exists, but doesn't matter that much. It is just the copy paste. And in the remove bit, what I do is I just do the erase function. So in the set of the current item, I just erase the person and the bid of it, right? And then I just modify this value, and that's it. And in the get highest bidder, what I ask is, oh, this was the thing, this was a corner case that I have to check if no one has bidded on this item. If this is the case, then I have to return -1. Then only I see what is the last element of this set, which is going to be our begin, right? So we get this iterator of the last element, and we find the second element for this. Now, what is the second element? So we know that in the set we have stored the bid and the user ID. So the second element is the user ID, and then we just return it. So that was it for the third question. It was pretty easy, like you don't have to think in the algorithmic way or something, you just have to choose some data structure, and that's it. Yeah, although my this code has like pretty high runtime and memory, but doesn't matter that much because my speed was high. So now we come to the best question of this contest, and like most of you are here in the stream for this question only. So this was like amazing question. Let's read the question. Okay. The name of the question is lexicographically small string after deleting duplicate characters. So in this question, we are given a string S that consists of some lowercase English letters. And in this thing, we can perform some operation any number of time, right? Any number of time we can perform some operation. And in the operation, we will choose some element that appears at least twice in the current string S, and we will remove any one occurrence. And we have to return the lexicographically smallest resulting string that can be formed from this. Okay, this was like amazing question. So the method I did is pretty like intuition based. I didn't know about anything, so I just keep taking some observation and just finding, and then do this code. But after the contest, I found that there was also the better approach using the stack, but it was like pretty hard to think of the stack approach unless you have done some question like this from stack sometimes ago, right? So let's say, okay, let's just take some test cases and just think for it. Yeah, before it, just give me 1 minute. Mm, let- okay. So let's get to this thing and let's take any random string and try to take some observation or something what we can get from it. So let's say the our string is something like A B B A. Let's say some big string like A A B C B B A A C C B, right? And then I know that I want to have the lexicographically minimum element, right? So let's say the observation one is the first thing. So the first thing I care about is the first index in the string. First index in the string. Then second, then so on. Right? So in this, what my first goal would be, the main goal would be having the minimum character at the first index in my result string. Then if I have done this, then my goal would be to have the minimum element at the second position, because that's what we mean by lexicographically, right? Like, like if at this position, like we have a bigger element, and even what I mean to say is that like this thing is smaller than this thing, right? Oh, okay. So we don't care about how many letters and what are the letters in the right side of something if the first element is not changes, right? So the main goal would be about first element, right? We have to find something for this first element. Okay, so let's say letters. Of course, I can remove B, and what about A? So because there are many more occurrences of A, so I can also remove this A. Then what about this B? I can also remove this B. What about this C? I can remove this C also. What about this B? I can remove this B also because there is a B in that case. I can remove this A also because there is a in this point. I mean, what do I mean is that I can remove all this string also because I have A at this point, and I can, oh, well, just a second again. That's better. So, right. So we just seen that I can remove all this string to this string of length 5 to this string of length 6 to. I can delete this. I can delete this thing also because yeah, for all elements there is some occurrence in the right side. But I cannot delete this whole string. So I cannot have this C as the first place, right? I cannot have this C in the first place because I cannot delete this string. Why cannot I delete this? Because there will be then no A in the remaining string, right? So I know that I will have some continuous string, right? Or some continuous string of letters, and for all of the letters, I can make it as the first element of my current like answer, right? So like it's just clear, like because we are thinking about the first index and having the smallest character at the first index is our main goal currently. We just finding that how many characters are there from which I can have like for which I can make it as the first element. And if some character I want to make it the first element, I have to remove all of the elements which are before it, and that I do. And now like when I have this like list of some elements which I can make that first, I will just going to compare these elements, and then we will choose the best possible option, right? So I will see the range of the characters I can take. And then greedily, greedily, in the greedy way, I will choose the best element, the smallest element, right? Is this clear? Because like if I can, if I take some element more than like bigger than this element, then the string would be like geographically bigger, right? Okay, so this is our like observation too, that we will now see for some range of the element and then choose our maximum or a best. So now the thing is now like around 70% completed. The only problem is now something like this. Let's say CBA, BA, and we have ABC or something, right? So okay, so let's say I know that I can make till I can make this much element as the first as the first value in my resulting string, right? I can have this C as the first, this is B as the first. I can also have this A as the first. How? How? Because I will just delete this string and now delete this whole. Sorry, delete this string and now I will have this A element as the first. So I have this string. So now in this thing, I can say that the what is the minimum element? So in this, I will have the minimum element. Minimum element is A. But now the problem is which A to choose, which A I should choose, right? This is the problem, right now because I have this three elements for all. I can make it as the first element in my resulting string. So which A to choose? Like, should I choose this A or this A or this A? This is like a pretty good question. Like, how do you know which A to choose? So let's say what will happen if we choose some A, right? If we choose this A, then I know that the whole string would be cut down, right? Whole this big string would be cut down, and then I will have in the resulting string, right? So what I'm saying is that let's say we just choose this element to be the first index in our resulting string. So for that we delete all of these elements. So now our resulting element is A. Now we must add this B into the string because it is the last occurrence of B. So I add this thing too and this C to write. Let's say what if we choose this A as the first occurrence. So we just delete these two elements and now I have this A. But now again I can have this A. Then again I can have this A. Then BC. And this thing is now lexicographically smaller. This means that this is the better option. So even if you don't want to prove something, you just take some test cases and then you just find that we should take the first element, right? So that's how I found out in the contest that we should take the first element. Is that clear? Also that like if we have to prove, then we can choose something like that. Let's say if we can choose this A, and then also we can have the option to delete this string, right? So that was something like proof, but that we just don't think about just now. So we found that we should choose we should choose the first element, first occurrence of the smallest element. That's it. We should choose the first occurrence of the smallest element in the current range in the all values, all characters I can have. So how this is going to be work is like I will see for all of this, like I will see for the first element. So now I can have something like two pointer or something which stored from this range. Then I will find what is the smallest element in this range. And my answer would be A. Then I would just delete this element and add this A into my answer. So now my answer would be 1. Then now check for this thing. How will I check? I will check that how many thing I can take. I can take this A, this A, this A. And now here comes the important point, important observation, right? Now you can also delete this A. Like when we are choosing for, the first index, we cannot delete this element. But now, because we have already taken this A, we can also delete this element. So now our range is going to be this thing, right? We can have either of these four elements as here as the second index, right? On the second index. So this was it. So this was an important observation. So if I have already taken some point, some character, then I can take it here, and my range would be now bigger. And I take okay, so I take like I have these four options, and again I will take the A, the first occurrence of the smallest character, which is A in this case. Again, I will delete this B, take this A in the string, and now I have to think about this thing. I can delete this element. I can delete this element, but I cannot delete the B because it is only the one. So then I have to choose from these two elements. I will choose that A, and now we have B, C. Then we will choose B, and now we have only C, and I will choose C, and that's it. So that was it. Okay, but now there is a slightly there is a small edge case or small corner case, you can say, which is this thing will not work for some particular point. Let's say. So let's take some cases for when our string is like a or this a. So if we try to have like if we make the resulting string by this method, what we are going to do is that will choose how many things I can take. I can take all of this as the first element. I will take this first element. Then I will choose from these two, this one and this one, right? But but we can also make we can also make only this A, right? I delete these two elements and now I have only this A. And we know that this A is smaller than A. So that's what we have to see, right? Now, what was the observation in that is like in these cases, if we delete some A, like if I am at this point and if we delete this A, then I know that I have to take any of this B or C. I must take this, but this thing would be bad for me. So therefore I take this A. But in this, I know that if I don't take this A, then I will have the empty space in this, right? I will have nothing in this, and nothing is better than A, right? That was a smaller edge case, and how we will going to include this, we will see that in the code. Okay, so let's try to see the code. Okay, so let's try to make think that how we are gonna code in this, right? So let's say we will have some frequency for all of the elements, and then for each element like I will have some range. So LLP1 would be like currently where I am. So and P2 is the rightmost element, right? And I will know that I can take the element from P1 till P2 inclusive, and then I will choose the smallest element, sorry, first occurrence of smallest element, then just delete this thing, and now I will make this P1. Now this P1 would be equal to the index of this first occurrence of smallest index plus 1. Why? Because we know that, like, let's say for this test case, right? So we know that, assume that we are finding the first element and our range is like this thing. And now I take this A, so therefore I delete these two elements and take this A in the string. So now I have just taken care of this first C element. I don't have to think more about them. I will just take, now I will start from this element, right? That's what we are doing. We will make this P1 is equal to this element plus 1. And then we will increase the P2 if possible, and then we will just doing this again and again in a loop until we just we just see for all of the element, right? This P1 comes to n. Okay, now let's see the code. So what are we doing in this code is we have taken this input string as I have taken the string answer, which is currently empty. The n is the size of this string, and now I have made this three like containers. Okay, what do I mean by these containers, and what we'll do by these three things? So again, I was in like very hurry in the contest, so I just did this in very speed. This is not the most optimized approach we can use, but yeah, it is the valid approach. What is this? So this total of the 26 length, this total array of the 26 length will store the frequency of some element of some character in the whole array. This used array of this 26 length will give me uh, let's write here, this used of I will give me, if I have used the ith character, sorry, the this a plus I, right? This character in my resulting array, the current of I is the frequency of this a plus ith I character in my current current range. Now this thing is kind of confusing. I know when I wrote it, it was also kind of confusing for me. But what we are doing, let's just see this by a test case. The test case, we just take this one, CBA. Uh, sorry, this test case. So let's just see for here, right? CB, CB. So I know my total array is just going to be like 3, 3, and 2, which are just the frequency of A, B, and C, right? Well, yeah, all other frequency are going to be 0, but we don't care about them for now. Now, the main confusing part, which is the current one. So what do I will see in this? Okay, what I have to do is I have to find if like I have to check na that if there is some if I can take this I can delete this element, right? And how can I say that I can delete this element? So I can delete this element either there is some element in its right of it, right? There is some same element that is in the right, so therefore I can delete this thing, or so I can delete the ith element if there is some element in the right side, or the one more case, right? Let's say I have just taken this a in my resulting string, right? I have already this a in my resulting string, right? Now I have at least one a, so I don't care about them. Or so what do you mean with that? I have used one character of this in the resulting string, resulting answer, right? So is this correct? So this was it. So I just have to find this thing. I can find this by my this used array, and I can find this right side by many more cases. I will just say how many I can have like how many a I have used till now, and I will the this and then I can check the total frequency of this a and the frequency of a's I used in this current segment. And that's how, so there are many different approach to find this, right? I just have to find that if there is some element of the same character in the right side of it, so that I can delete this thing, right? That's it, right? So we know the use of this used and tot. You might be confused in this current one, but you will know in the word next, right? So what we will do? What I do in this is first thing I want to clear is sorry that I have used the pointers like P2 and P1. So my P2 is the first pointer, it is the left pointer, and P1 is the right pointer. So just think with this thing in mind, right? Take this thing in mind. So how do I initialize this thing? So I know that I know that I can take the first element. So that like we are now at the first element. So my P2 is equal to 0. So in currently we are at the first element, and P1 is equal to 1. So P1 is equal to 1, meaning that currently I can come at sorry, I can make this element as the first one, right? So this thing is clear, and I will say that I have used this element. What do I mean to say is that I want to initialize this thing. So let's say the thing is like this, then P2 would be the 0th element, which is this one. P1 is in the initial condition. I know that I can delete this A and have this B. Therefore, the P1 will be B1, right? And what this P1 shows that I can have this till this element which can come as the first position or the best position you can say, right? So this is my P1 storing. Is this clear to you? After that, this is a while loop for the P2. I will end when this P2 is come to end, right? And now I will find that how much right, how much in the right side I can go. So this is the main point, right? This is like the heart of the this code. What I do is I will say I will say that until the P1 is less than equal to n. And remember that we also have to see the case when we can have the empty, like we can delete all the element and now we can have this empty character at the first place. And this empty character would be the best thing for us. Is that right? So okay, just don't care about this. This is just the condition. We will check that if the last element, if the last element is not equal, sorry, the current of last element. So what do we mean by that is the number of element we used in the current segment are not the total element of this segment, then we can go ahead. Else, I know that I cannot delete this P1 minus 1th element. I cannot delete this. Because I delete this, then there will be no element at the right side. Then I will delete this. Okay, so if this is not the case, I will delete this P1 minus 1th element so that I can have this P1th element as the first index. Is this clear? So now, if this thing is not n, I would just add this thing to the current element, just saying that, hey, now I am also adding this P1 in my current range. That's it. If P1 is equal to n plus 1, that means that we are now at end. Okay, and if P1 is equal to n plus 1, if P1 is equal to n plus 1, that this thing mean, this thing mean that we can take the empty string. We can take the empty string and therefore we will delete all the things and have the empty empty string, right? Or empty element, or you can say nothing. We just delete all of the elements. So this was the case. We just break in this case. Else what we do is we find what is the smallest element in this current range. So I just find for all the element if there is some occurrence of this height character and if this is true, I just take small is equal to I and break the loop. So I just find the smallest character which is currently in my range. Then this thing is very confusing, right? Then what I do is unless so I just start to move, right? Just say in this case my P2 is this thing and the smallest character I found is this one. So I will now start to move until this, right? And this and come till this A and will take this A. All of the elements before this, I am just gonna delete them. This element, going to add this in the result and then my P2, which is the left pointer, is going to be here. That's it. So until I come at the smallest element, what I do is I do P2 plus plus and this thing I just remove them from range, my current range, and also remove them from this total. Like I'm just skipping this element, right? I am skipping this element, so therefore I can delete this from the total range, right? You can think of them as like they never existed, right? Because we are just skipping this. Then at some point I will just stop at this P2. Sorry, my P2 would be the pointer for this smaller, the smallest character. So now for the smallest character, I will say that I have used this character. I have used this character. Then remember this thing, important thing. Then I will remove the smallest character, the one occurrence of the smallest character from the current string, and I just add this in my current answer, and then do p2 plus plus, going to the next element, and that's it. I do till this. My left pointers come till n, and I guess that was it in the code. So it was kind of uh, hard, but not that hard if you think in a particular direction and take some test case and go observation by observation like this thing, right? First observation we take this, that this thing is lexicographically, so we only care about the first index, then second, then third, and then so on, right? Then the second observation we take is we will have some range of characters, and in the greedy way we'll take the smallest element. Then we just we just say the small edge cases, and then how we will do the code, right? Okay, so this was my approach. That was not the best approach, but I just walked observation by observation and tried to do the code. Now, there was also one better approach than this. One better approach. One better approach. Okay, yeah, one better approach, which was using the stack. Now, this approach was kind of hard to come in your mind in the contest if like except you have done some question of this type, right? So in this stack, what we will do is we will like iterate over all characters, and let's say in the stack, in this stack, we will remove all the we'll remove all the occurrence. Let's say okay, let me be clear. So let's say I am at the ith character, ith position, and the character at this position, character at this position is x, right? So I will see in this stack, and I will say that like if the top element in the stack is greater than x, and I can delete this thing. I can delete this top. Sorry, delete this top element. Okay, so first let me be clear. What do I mean by I can delete this top element? I can delete this top element only if it is not the last occurrence of it, right? There are some other occurrence left. Then only I will delete this thing and have this smaller x so that it will have my my resulting string would be the lexicographically smaller. And yeah, just you just have to do this thing only, and then the the stack in last would be your answer. Would be your answer. Okay, this was a pretty good approach, and I will say that give some time about thinking this approach, and what some other type of question can be made by this like stack type of approach, and why this stack is working, and try to make something like observation that in what type of question, in what cases this stack approaches can be worked, right? Because this is like a fundamental approach. So I guess that was it. We have solved all the four questions. If you have some doubt or something, you can comment it now, and also you can comment it after the stream. I will be ready to solve your doubts, and I guess that was it. So keep solving and keep